So first, I've not graded the homeworks yet. I'm still getting them. I think I have just about everybody's. So my goal is to have them back to you on Monday. Um, One thing is, I prefer that they be stapled or at least paper clipped. If I get several pages loose, you should have your name on each page. And actually, numbering would be a good idea too, because that way I can make sure that no page is missing. Because yesterday I get here, I open my door, and there's a big pile of assignments, and one assignment did get separated in two, just from pages being strewn all over the place, and I had to. So it's like putting Humpty Dumpty back together again. So protect yourself, and preferably submit your homework in one piece. Also, another option, especially if you're in a situation which, judging from the mess under my door, a lot of people were in, coming here late and turning it in. You can also take pictures of it and send it to me. It's actually pretty easy to scroll through my phone and grade it. So, and then I would email you back with what you got and why you lost points. Okay, now.
So this is the second homework still due Monday.
Yes. Now, the test. But you can turn it any time during the day. So if you don't have any time today for any questions on that homework, you can also use Monday's class for questions. First test is not too far away. The 15th. And the coverage is it's chapter 2, except we are skipping 2.4. So whatever material remains is going to be covered next week. The Monday before the test, the 13th, we're not covering anything new. That's going to just be review. And if you go to the lectures page, there is a practice test and a solution. So if you look at it now, you won't have seen all the problems yet, but in time you will have. Okay. And I'll put some sort of bonus problem in there. So there's going to be 7 regular problems, and then bless you, and then 1 bonus problem. So the maximum score you can get is 120 out of 100. And last time I taught this class, a few people pulled it off. Now, so with that in mind, what I'm going to do now is hand out all of the homework assignments that apply to this test. So there are 3 of them. So so just send those around. And okay, so what you should be getting is problem sets 3, 4, 5. So make sure you actually get those. Of course, I'll have them up. They're not up on the site. Not all of them are up on the site yet, but I will do that later today. Now, because I didn't want the deadlines to be too bunched up. So, for instance, problem set 3 is due Monday, but problem set 4 is due. The original due date was Wednesday. Bumped it back to Thursday. But also what I did was I shortened it compared to what I gave last time. So yes, you're going to be busy doing homework, but to get yourself ready for the test. The last problem set that I'm handing out, number 5, it's not actually due until after the test, but you have a choice to get started on it as soon as you can to help with your test preparedness. But certainly the practice test will tell you, here's what it tells you and what it doesn't tell you. We had some problems with this last semester that maybe seriously consider for the first time not giving practice tests anymore. But you guys, one more chance. So what it tells you are, first of all, how many problems will be on the test. Also, what type of problems you can expect on the test. So for instance, a linear equation, a separable equation, modeling problem like I'm covering now. Problems corresponding to the other types of equations that you're going to see next week. So it gives you an idea of how the material is distributed too. What it does not tell you, it does not tell you exactly what functions are going to be involved. Whatever kind of integrals you may have to work out while working a practice exam, you'll have different integrals to work out on the real thing. Comparable difficulty. So it is meant to give an indication of, okay, let me rephrase that. A rough indication of level of difficulty. But we've had situations where on a real test, someone's taking too much from a corresponding practice problem. So don't do that. It's meant to give an idea. Okay. Now, in the interest of helping with your test preparation, giving ideas to what you need to do, I'm going to give you a little assignment that is actually comes from an assignment that I've been given. So I'm attending this weekly teaching workshop, and what I'm required to do is take some technique that was covered there and apply it in one of my classes. So today, you guys are guinea pigs, but I'm hoping this will help you. So with that in mind, so I'm going to hand this out, and it's very important that and I've never tried something like this before, and I really do want to know what you guys think of it, if you think it might help you with your test preparation, or at minimum serve as a wake-up call. So follow the directions closely, and that's why I used very large fonts in some cases. So don't blow that. All right. Okay. So what this assignment concerns are the kind of equations you dealt with in the first homework, a linear PDE. So what you'll see on the first page, and for now only look at the first page, is a quick summary, like, okay, here's the kind of linear equation, general linear equation that you've been dealing with, y prime plus py equals q, and just a reminder of what the solution formula is. By the way, has anyone looked at the practice test? Because it's been up there all semester long. Okay. You will see the very last page is a formula sheet. So you will have something there. This is not a memorized test. Because a lot of these things can be easily looked up. And that's so you'll have an idea as to what sort of things you don't need to commit to memory. But it's important, you have 50 minutes, and you have to allow time for a brain freeze. So it's still important to be able to apply the techniques quickly, so you shouldn't be spending all your time learning what's on the formula sheet during the test. Okay. Excuse me. Yeah, they're still being handed around. Okay. Get my phone stopwatch ready. All right. Okay, so take a moment to look over first page just to have that solution formula fresh in your mind as if you would be studying. But one of the focuses of this exercise, I want to try this out on you guys, is speed. Because a lot of times you're studying and practicing problems, and you're taking your time that you really can't take during a test. Now, I was going to call this like a pop quiz, but that has connotations that I was anxious to avoid, so that's why I'm calling it a test simulation. Yes, it's a little unusual. It's unusual for me too, but I figure let's just give it a shot. Okay, so so when I say so, go ahead and flip to the next page and do what you're told there. Ready? Go. Well, I'll give you 5 minutes. Let's see some hustle there. and stop. Okay. How many were able to get all the way to an answer, in other words, involving a plus C? Okay. Now, I will confess that in one respect, I blew it on this because the intent was, and I wasn't thinking through this enough when I was making up a problem. I kind of just made one up. And in particular, I was focusing on having a simple integrating factor at least. And it was not my intent, and I would have, so when I reflect on this later, I'm going to have to point out one of the challenges in this. Be careful what problem you pick. I did not mean to have a problem where you apply integration by parts twice. How many of you at least got to the point where if you have a solution formula, okay, how many of you at least had something got as far as that? Okay, so the majority of you. Okay, so the idea is you're having to do all these things that you know how to do. You know how to put in building blocks. You know how to do integration by parts, but trying to do this under time pressure, that you really have to have your ducks in a row more than usual. And the key is to and that's why practice is so important, because a lot of times, especially when we're learning things first time, there's a lot of doubt as to whether you're doing things the right way, and during a test, you don't really have time to question yourself. You just have to act, and a lot of times you mentally become your own worst enemy, and end up taking a lot more time than needed. So, okay. So, and does anyone have any thoughts about this exercise in terms of I know it's kind of an open-ended question, but I actually do want open-ended feedback as to trying to simulate what's happening on the test.
So in a normal test, we won't have to do the integration by parts more than once.
This is a differential equations class, not a Cal 2 class, so the intent is to have you spend more of the time during the test focusing on new material that's specific to this class as opposed to spending all your time integrating. So, integration by parts may come up, but not something that's as onerous as this. So, okay, so my bad on that one.
Could you go over like the solution?
Okay. So it's y prime plus is equal to 2y plus t squared. So it's important for. Well, let's just let everybody see what's on the board. Okay. So u is t, dv is e to the minus 2t again. dv is just dt, so it means you're going to get something easier to integrate that can be integrated directly the next time around. And then your v is the same as before, minus 1/2 e to the minus 2t. So you get what you had before. And then you have minus the integral, plus u times v, so that's minus 1/2 t e to the minus 2t. And then you have minus the integral of v du, so you get plus integral of 1/2 e to the minus 2t. But now that can be integrated directly. So you get e to the minus 2t over minus 2. So you have minus 1/4 e to the minus 2t, and then don't forget the plus c. So if I had given an initial condition, then then you would use that to solve for the plus c. I realize I have to go for that fast, and that's because of time, but okay. So But questions about the process. All right. So certain things need to be a reflex. Often, especially in this kind of problem, you can have exponentials, those are your most common integrating factors. So knowing to divide by the coefficient of t. And then u times v du to set up the next integration by parts if there is one. Okay. So after I after I wrote down the solution, I thought, well, I have some time left, and I'll try verifying it. Except I mistranscribed. I'd forgotten to write the -1/2. It's like, why am I not getting a right solution? Well, that's why. Okay. The questions about this? All right. So now that this is hopefully served as a wake-up call to how fast you need to be, there's still one page left. So I'm going to give you a similar amount of time. 3, 2, 1. Steps aren't written this time, but go ahead and follow them. You just did it. Okay. How many finished this one? Okay, I saw that compared to the last one, there were more people who were just sitting there waiting. So, okay. Now, for the second one, solution turns out to be t cubed plus a constant times t squared. How many got an answer involving t to the fourth? Anybody? Okay. One careless mistake you might make with this kind of problem is because it's not in a standard, nowhere near standard form, because you have ty prime equals 2y plus t cubed, and you need to have y prime isolated, so it's necessary to divide by t before you do anything else. So for instance, focusing so much on getting the p correct, because that is for your integrating factor, and you forget to divide through all the way. So what happens in this case, this works out a lot more nicely than the other one, because your p is minus 2 over t, so your mu is e to the integral of that, and you get e to the minus 2 natural log of t, which simplifies to 1 over t squared. So you end up only using a power rule. This time there are no exponentials. So a problem might, after you get in this form, it might seem to be more of a pain than the first one. Actually turns out to be either not having to do integration by parts. Yes?
How do you do that last step to get 1 over t squared?
So you use the properties of logs, because natural log of x to the y is y natural log of x. So here I use this property to move a minus 2 up here. So what you get is e to the natural log t to the minus 2. But e and natural log are inverse functions of each other, kind of like square root and squaring. So they cancel out, leaving you with t to the minus 2. Yes?
Is it safe to say that anytime you end up with ln in the power of your exponential for the integrating factor, you're going to end up with a non-exponential integrating factor?
In the simple cases, we tend to see yes. I have to be careful making a blanket statement like that. But yeah, what happens is, if you get, anytime you have, like a constant over t, yes, so this was going to happen. You're going to wind up with something like that. Yeah, it's pretty common. It's a good way to give a straightforward problem of this type that avoids integration by parts. And that was actually intentional. Okay, so one thing I'm curious about is, having gone through this, because this is not the sort of thing that a professor will subject you to in advance of a test, do you see it affecting how you go about studying when you get to that point? Yeah. Because it's something I've informally encouraged students to do, is it's not enough to simply know how to do a problem. Say if you did very well in all the homeworks, because on a test you don't have all the time in the world like you do in homeworks, and it's important to get your speed up. Another thing I've often told students more in a one-on-one setting, but it's certainly worth airing here, is when you're learning things for the first time, you're going through it very methodically, you're trying to absorb this, you're trying to internalize it, and how you go about it on a test is completely different. Because that's when you have to let instinct take over. Because our conscious minds are really awful at executing when you really didn't execute efficiently. Because we want to take control of things, think things through. It's very difficult to get yourself to basically surrender and let your unconscious mind take over. But it's something that I learned to do when I was an undergrad, and that's why I was a great test taker. Another thing I've observed here at USM especially is how little time on an average sense you all take with tests. You get a 15-minute test, and how many of you are out of here in half the time, not because you did it all, but you decide, oh, that's all I know, but I don't know what the reason is, but or just giving up. There were times, many times as a student, where I come across a problem first time and I don't know immediately what to do, and that's of course the time when you're inclined to panic. And I would stop myself from doing that, move on to another problem, come back to it, give myself a chance to recall whatever it is, and sometimes that would actually happen. But you have to give yourself that chance. So even though it's a time to freak out, that's what you have to suppress at all costs. I would actually do a little bit of meditation before we go into a test. And before you say, well, life's not about taking tests, how realistic is this? No, it's not. But life is about executing efficiently. You have whatever it is you do, things have to become second nature, and that's how things really get done. Not that very few of you will be actually using integration with parts in the spot anytime soon. But yeah, try doing this on a hobbled IQ. You just never know. Okay. So any other questions or thoughts or whatever? Yeah.
We can go first.
What was the solution?
Oh, for the second one?
Yes.
That.
Okay, sweet.
Could this be like put on the resource pages so we could like work on this as well?
I will put it on the site. Yeah. Yes.
With the solution, if you do plus C times T squared, will you accept just plus C, or do you have to have the?
Well, the thing is, if you look at solution formula, and that's why I put brackets around it. But one over your integrating factor has to multiply everything that's in here. Now, if you want, you can leave it outside. I don't care about that, but yeah. That what you were asking?
Yeah.
Oh, yeah.
It's just like the constant, like since it's arbitrary, doesn't matter, or.
Right. Yeah. So, So, for instance, like that. Yeah, that's fine too. I'm not particular about the form of the answer. I just want it to be mathematically equivalent. Okay. Other questions? Okay. Well, that was interesting. Yeah. And now for my assignment, I'm have to write a reflection about this. And the asked questions are way too detailed, considering that this wasn't really a big production. And someone's going to grade it. So someone outside of USM. And so.
Did you say not to write our names on it?
I don't care if you do or not. Okay. Even though it doesn't count for a grade, a good reason to write your name on it is that if I see something in what you did, then I can give you more individual feedback on it. But it's totally your choice. Okay, so yeah, go ahead and pass this forward. Okay. Now, here's another challenge that I reflect on is this much last time, but I think it was time well spent. I have just a little bit more to talk about from the previous section. Okay. So that way we're not behind going into next week. So the example I was in the middle of is we had this equation, the financial application, where S is the value of investment, R is the rate of return, and K is annual investment. So the solution that was derived at the end of last time is K over R e to the RT minus 1, under the assumption that there's no money down. So there's nothing in there at first, and then these annual investments amount K keep pouring in. So as an example of that, let's assume that the rate of return is 7.5%, so 0.075. One of the more heartbreaking mistakes is in the heat of the moment improperly converting this to a decimal. Okay, and the goal is, so the problem is, what is K given that after 40 years of investment, we get $1 million. So what you can do is we can solve this equation for a K. So T is equal to 40. So now I can use my solution formula. So we solve 1 million is equal to K, which is our unknown, over R, which is 0.075, e to the 0.075 times 40 minus 1, and we solve this for K. So first, any questions about where the equation comes from? So whatever information you're given, go ahead and plug that in to the solution formula that you have, and then we'll select just one unknown to solve for. So now what you can do is, so for instance, I can, you can work this out on your calculator. You can move this to the other side. So basically you're multiplying both sides by 0.075. You're dividing by this. So the algebra is not very involved here. And so you can try this out. And what you will get for a value of K is roughly $3,930. So let's think about it for a second. If we take $3,930, and you're putting that amount in every year for 40 years, so the total outlay is not very much at all. So turns out to be roughly $157,200. But because of the accumulation over 40 years, especially what's put in at the beginning, because that accumulates even more, because it's exponential, that is what causes this to grow so much, but also over a long time. So think of this as a reason to, as young as you all are, you can start thinking about retirement anytime now. So
What is K again?
that is the annual amount that is
I
invested.
meant the number that you.
$3,930. Okay. So that's one kind of problem that can come from this. Another kind of problem, and we'll stick with the same scenario, same solution formula, just different information. That now I'm going to fix K. K is 2,000 a year, and we still want $1 million after 40 years. So that is your T value. So then, the question is, what does R need to be? Now we're talking only 2,000, so you can expect that the rate of return is going to have to be substantially higher, kind of like Madoff levels. So, in other words, never happening. So S of 40, which is from a solution formula, K, which is 2,000, over R, which is unknown, e to the 40R minus 1, and that is set equal to $1 million. Now, in this case, the algebra is going to be a little more involved. So what you can do is divide both sides by 2,000, and you get 1 over Yeah. Actually, the algebra is going to be so involved it would be impossible. And the reason, so no, I won't put this on a test. Because if r involved in two different ways algebraically, here's an exponent and also here's in a fraction. This would have to be solved numerically. Take 460 with me next semester and you'll find out. It's various methods using initial guess. And what you would get from that is 9.77% would work. So you might have thought that it should be much more than 7.5 from the previous example. Yes, I hear people leaving, but I have 2 minutes. I'm taking it. But it didn't have to be that much more. The reason why is because it's exponential growth. Small tweak in that constantly exponential makes a big difference, especially over time as long as 40 years. Okay. All right, so it wasn't quite made up level, so maybe still doable. Okay. And I mentioned in the notes a couple methods that could be used to actually come up with this approximate value of r. The last point I want to make is for a slightly different application of this same equation. So instead of that would be relevant to you guys, or hopefully not, but likely is to some of you, loans. So you have the same equation, therefore same solution formula. But in this case, K is the annual rate of payments, and that is negative. So the idea, and also your initial condition, instead of being 0 like last time, is the initial amount of the loan. R is the interest rate on the loan. So what you can do is get an idea as to how long it'll take to pay it off, because the idea is you work out a solution formula which has an extra term compared to the other one because you have a non-zero initial condition. So what happens is you get your solution formula, you set, and you want to find out, it's like set the balance equal to 0 and solve for t. And then t will tell you how long it takes to pay off a loan. The other thing you can do is once you figure out how long it'll take, so t times k, where t is in years, total payments. So tk minus the initial amount of the loan is the amount of interest you paid over the life of the loan. So you get an idea as to how much extra you had to shell out for the actual cost of that credit, at least estimated. Okay, so same situation, just that the sign of k, positive or negative from different applications. Okay, now you can scramble.